Boom, Mr. Mayes is here again with you. Back here, new video. Seems like forever since I made a video here. But here we go. Got to keep making these videos, right? Got to keep getting some help out there for calculus, statistics, algebra 2, algebra 1, math 1, math 2, math, whatever math you're in. This in particular is for calculus. Let's take a look. Today we are integrating logarithms. So let's take a look at some integration involving natural logs. Yeah, let's do that. Let me shrink myself. Okay, so when we're doing the natural logarithm, we already did the derivative. The derivative of a natural log is 1 over x. So we're just going to go backwards. If we take the derivative of natural log, we get 1 over x. So that must mean the antiderivative of 1 over x is natural log. Now, notice here that I have these absolute values. It's because we know that we can't have a negative value in there for a natural log because, well, it doesn't exist there. So we have to be careful when we're doing these things. So, right? So I've got these rules here. The integral of 1 over x is equal to the natural log of the absolute value of x plus c, of course. And then we have our reverse chain rule where we have the integral of u prime over u is the natural log of the absolute value of u. And, that seems kind of strange, but I'll show you an example that should make a lot more sense, basically using the idea of reverse chain rule. Let's take a look at a few of these problems here. Whoa, man, come on. Although it is true that both d, equals 1 over x and ln x and is 1 over x, it's only because the negative, right? Remember, this cannot be negative. It's not in the domain. That's why the integral of 1 over x is ln of absolute value of x. You should not leave off that absolute value. So we've got this here. Now I like to change this. Whenever I have a number up on top, I like to just bring that out. It makes a lot more sense to look like this. Let's make this bigger so we can see it. So the integral, this right here, right, that part right there is negative 3 ln of absolute value of x plus c. Okay, so why can't we do this as, let me make this red so we make sure we don't do this, right? Don't do this. 3x to the negative 1. All right, don't do this. Try to use a power rule. Some people will be 3. Oh, what happens when I add 1 to negative 1? X to the 0, and then what are we supposed to do using power rule? Divide by 0. What? You're going to blow up the world? You're going to cease everything to exist? No, we don't want to do that. So we're going to make sure we don't. So we have over x, when x is a power of 1, we're going to use a logarithm. So that's the general thing. When we have x a power of 1, we're going to use a logarithm. But maybe sometimes it might not be a power of 1, in which case we need to use reverse chain rule. So let's take a look at an example that does just that. So what we should always do when we have any type of rational expression in my integral, is take a look to see if I can take the derivative of the denominator. So if I take this guy right here, this sucker down here, if I take the derivative of that, does that equal something that looks similar to the numerator, but just missing a constant? Let's take a look. If I take the derivative of the denominator, I'm going to get 2p. Only if you drink too much water. Okay, I'm going to get 2p. So this is, in fact, what we have up here, except we're missing a constant, right? We're missing 2. So this is a reverse chain rule. What I would need to have happen, come on, man, is I would need a 2 here. Okay, this is my hook. This is my hook. So if I have the hook, all I need, if I have to put the 2 in there, I got to put the 1/2 out here. All right, so my hook, and I'm going to rewrite this guy so you can see what my hook does. My hook is going to go right here. Okay, that's my hook. And I'm going to have 1 over p squared plus 1 dp. Okay, this right here, this is the part that I'm really concerned about. So I'm going to have 1/2 natural log of the absolute value of all the stuff that's in the denominator. P squared plus 1 plus c. Okay, that's using the reverse chain rule. Now, if we look up here and we're kind of seeing this like this, so this is u, this right here, this right here, this right here, this part is u, and this part right here is u prime, right? That's u prime, okay? So that's how that relates to the reverse chain rule problem. All right, let's take a look at number 3. All right, number 3 is very similar to that. Remember, again, what you need to do is look, if you have a power down here, you're going to look at the bottom here. You're going to go, hey, look at the bottom. Self, look at the bottom. If I take the derivative of that sucker, let's call that u. Let's call u t cubed minus t squared. That's a strange thing to call you. Don't call me that. If I take the derivative of that, I'm going to get 3t squared minus 2t, fruit t. Well, that is very similar to what I have right here, right? I have 3t squared and I have 2t. Well, if I factor out a 3 from the top, I'll end up with what I need for my hook. Excellent. So that's what I'm going to do. I'm going to factor out a 3. And I'm going to have 3t squared minus 2t. And I'm going to have 2t cubed minus 2t. T cubed minus t squared. Okay, so I factored out a 3 from both of these. I brought it out. And I end up here with what I had for my derivative, which ends up being my hook. So then I'm going to have 3 natural log of the denominator, t cubed minus t squared, plus c. Boom. Bada boom. Nailed it. All right. So let's move on and take a look at some more examples that are on the AP exam that use these things with natural logs. So one of the things that's on the AP exam that we see recently, there was one of these on last year's test, is that how to integrate when we have to use long division. Now, long division happens when our powers here are the same. So if we have a same power, or if the power in the numerator is greater than the power of the degree in the denominator, okay, we're looking at the degrees. If it's greater than or equal to, that's when we're going to use long divisions. Just check this out. Do long division on the side here. So what we're going to do is on the side, we're going to end up doing some long division. So we're not going to set this equal to anything yet. We're going to do some long division on the side. So we're going to do x squared plus 2. And we're going to divide that. And we're going to put the numerator in here. And we're going to do some long division like we did in, pre-calc or algebra 2 or whatever. So we're going to need a 1 here because 1 times x squared is x squared. 1 times 2 is 2. I'll put that there. This is going to be a 0x. I'm going to subtract everything. Bam, bam, bam. I'm going to have negative 4x. These guys cancel out. I'm going to have negative 4x left. All right. So then what am I going to do next? I'm going to need well, no, there's nothing. There's nothing I can multiply here to give me, to x squared to give me negative 4x. So I'm done here. So I'm going to put minus 4x all over x squared plus 2. All right, so I'm going to put my remainder divided by this guy right here. And then I'm going to rewrite our problem. So I'm going to rewrite our problem as the integral of 1 minus 4x over x squared plus 2 dx. All right, now comes the tough part. I'm going to just separate these integrals because I want to just look at the difficult part, this guy right here. This one's easy, it's just x. So now what do I got here? I got one of those situations where I should see what the denominator is. So I'm going to say u is equal to x squared plus 2. So u prime is going to be 2x. Well, is that what I have on top? It's close. It's close. I have a 4x. I really want a 2x. So if I have a 4x and I really want a 2x, I'm going to take one of those 2's out and leave a 2x there. Now, it's a reverse chain rule. This being my hook, I'm going to have 2 ln of x squared plus 2 plus c. Bada boom, bada bing. Okay, bada bing, bada boo. Realist calculus in the room. How you doing? Okay, so there are some examples. I've got 2 more examples for you, but I will put those on. Actually, it doesn't look like they're too hard. How much time do I got left? We're at 10 minutes. We'll do this. We can do it. You guys stick with me, right? You can stick with me for a few more examples, right? 3 more examples. Stick with me with that. All right. Thanks for sticking with me. So, when we're integrating these things, we're looking at reverse chain rules. So, usually want to think about doing reverse chain rule integration whenever you have an ln x in your integral too. So if you see an ln in your integral, then you're gonna have to think, boom, hey man, I know this has got to be reverse chain rule. I gotta find a 1 over x somewhere in my integration here, and then I know that it's reverse chain rule. Take a gander, if you will, at these. So if I integrate ln x over x dx, all right, I can rewrite this guy as 1 over x times ln x dx, right? So ln x, the derivative of ln x is 1 over x. There's my hook. This is my hook. So this becomes a power rule problem. So I'm going to take ln x, I'm going to square that because I'm going to add 1 to 1. I'm going to divide that by 2 plus c. That's my answer, guys. All right, so whenever we see an ln x inside our integral, at least for calculus AB, we're going to want to find a 1 over x so we can do this integral by reverse chain rule. Let's take a look at another one. Oh, I see it. You see it? I see it. You see it. I bet you see it. You see it, don't you? Yeah. You guys are getting good at this now. There's 1 over x right there. Times 1 over 2 minus ln x cubed. I knew you saw it. You know what, though? I don't like that. Let's write it as 2 minus ln x to the negative third. Right? This is more appropriate for what we're going to be doing. So, oh, man. But you know what? What's the derivative of 2 minus ln x? Because that's the inside, right? That's the inside that we're going to need a reverse chain rule for. What's the derivative of that? That's negative 1 over x. Uh-oh, negative. Don't be negative. We got to deal with that negative. So that negative, we're going to need that right here, which means we're going to need a negative 1 there, which means this is our hook. There we go. We got our hook. And so we got to have our negative 1 outside. We have 2 minus ln x. We're going to add 1 to negative 3, which gives me negative 2. We're going to divide that by negative 2. And we're going to plus c that guy. It's good enough. Good enough for us. If you really want to, you can say this is 1/2 2 minus ln x to the negative 2 plus c. If you really want to. It's okay. That one looks fine. All right, let's go to the last one. Guys, I'm not even at 15 minutes yet. What? Whole thing, not even 15 minutes. Are you excited? I'm excited. Feeling good today, guys. Calculus. You gotta love it. You gotta love calculus. What is with this one? 1 over root x minus 1. What are you talking about? Whenever we see a square root in the denominator, our first instinct should be u substitution. All right? So in this case, we're going to make u equal to root x. Or we'll call that x to the 1/2. Then we're going to say u squared equals x. So I want the x to be by itself because it's much easier to take the derivative of x and just get dx, right? Because then we can have an easy substitution here. Okay, dx is 2u du. So making my u substitution, I'm going to have 1 over u minus 1 times 2u du. All right, so then I'm going to have 2u over u minus 1 du. Okay, so what's that gonna do? What are we gonna do with that? So why don't we do this? Why don't we do some long division because the u's have the same power? Oh my God, you're going, oh, my Estes. You are making this too hard. You're going like over 15 minutes now. I think I'm gonna have to stop and rest. Well, do what you got to do, guys. Do what you got to do. All right, so we're gonna have the integral of 2 plus 2 over u minus 1 du. So this one here is going to be 2u plus 2 ln of the absolute value of u minus 1 plus c. And we've got to put the u back. Put u back. So that's square root of x plus 2 ln square root of x minus 1 plus c. Folks, that's calculus. We'll see you again. Logarithms of integrals with natural logs. Thank you for joining me. Subscribe. Hey, if you're watching this new, subscribe. I can use the subscribers. Come on, help a brother out. Catch you later. Bye.